Hi, my name is John Smith. I'm with ExtraHop Networks, and today I want to talk a little bit about an integration that we've done to help with detecting golden ticket attacks. One of my favorite presentations ever is Black Hat 2017. I know it's a little bit of an old one, but it's a great one if you can go to YouTube and watch it, or here you can see the URL there. But they're basically walking users through how to leverage Mimikatz and golden ticket attacks to basically move lateral through an organization largely or completely undetected. In addition to kind of the funny crude drawing of a guy spitting his cereal out, the shock here is that basically when you create a user ID with a golden ticket, that user can be anything you want. The big thing is that that user does not exist in Active Directory and is largely invisible to a number of the countermeasures used by ATA, Microsoft ATA, or even a lot of endpoint solutions. So what I'm going to talk about today is a little integration that I did to basically check client principal names against Active Directory. So when I saw this, when I started testing a golden ticket detector, one of the things I noticed is that you could in fact name this anything you wanted. So here what we're looking at is basically an integration with a product called ManageEngine. They have a product called AD Manager Plus, and what this does is it puts an API on top of your Active Directory, and you can do a number of cool things like creating a user, creating an OU, but you can also reset a password, right? So if you see a user account that's running amok, you can change their password on them, right? And then, send the user an email saying, hey, we noticed your account doing this, we've changed your password, or you can even disable a user account. But more importantly, you can basically interact with Active Directory from your NDR product. So ExtraHop, we're a wire data analytics solution, right? We are network detection and response. And so if you think of the cyber security triad of your endpoint detection and response, your SIEM, we make up that sort of covert position, right? NDR, network detection and response. And so because we're on the network and operating from a covert position, you can't shut us off. And I'll drive that home here in a second. But basically, what we've seen is a lot of malware starts with disabling the endpoint detection and response countermeasures, right, through any number of means. Now, at the end of the day, the endpoint will end up what inoculates these systems, but during the initial breach, the malware typically will disable it. There'll be something, an image that gets loaded that actually has code in it. I've seen registry changes that you load an image and then it updates your registry, and now that disables the endpoint product. So those are some of the things where malware basically is able to evade endpoints. That's not new. That's been going on for a while. Where an NDR can help is that because we're on the wire in that covert position, when an endpoint has been disabled, we can tell that the endpoint's been disabled because we don't see any of the DNS lookups for Falcon or for any of the other endpoint products, Carbon Black, right? So those artifacts exist on the wire, so we can flag those systems where the endpoints are not, endpoint detection and response is not running. But in addition to that, we can observe the malicious behavior, right? You still have visibility because we're not dependent on being installed on the endpoint. We're sitting on the network watching again in that covert position. So here's my box, and let's just say the initial compromise has happened. They've been able to disable the network detection. They've been able to disable the endpoint detection, whether that's Microsoft, whether that's Carbon Black, whether that's CrowdStrike. So here I've got all of my handy tools to steal or to create a golden ticket, but I want to go ahead and I want to run it from PowerShell, right? I want to run it filelessly. So I'm going to invoke Mimikatz remotely from GitHub. So I'm going to come here to my box, and I'm going to go ahead and I'm going to execute this command. This is going to load Mimikatz into memory for me, and now I can start the process of leveraging these items to create my golden ticket. So here I'm going to go ahead and create a golden ticket. Let me just make this a little bigger. So I'm going to go ahead and name the user. There you see my old user that I was testing with was named Can't Detect Me. Let me think of another pithy name that I can use here. So we'll say the user ID is unknown. Let me think of one here. Let me get back. Let me see here. See if we can get this to go back. Sorry. So we're just going to call this invisible CPN, right? So this is an invisible client principal name. And again, once someone has a golden ticket, they can move laterally throughout your entire organization, at least through those systems connected to Active Directory. They can move laterally and basically do anything they want. I have an ID of 500, which is admin privileges. So there you see golden ticket for invisible CPN at bgc.local. So now I'm going to open up a command prompt with that ticket loaded in memory. So if we look at our box once this loads, we'll check a few things, right? First, IP config. Right, my configuration there is 192.168.0.40. Who am I? I am Jay Smith, and host name is Win10Dev. So I'm going to go ahead and I'm going to launch a remote shell on my victim. So here's my trigger or my detector that I'm writing, right? So here I'm basically I'm collecting the server principal name. I'm looking at the client principal name. If it is not a machine account, right, then I'm going to basically query this API and I'm going to ask it, hey, does this client principal name exist in Active Directory? So I've observed a CPN. In this case, I might dial this in and look just specifically for KRBTGT, but I've observed this client principal name. I want to know, does it exist in Active Directory? Especially if maybe you could limit this down to, hey, client principal names that access specific SPNs or client principal names that access specific, critical assets. But here I want to basically check the client principal name against Active Directory, and again, we're gonna use the API provided by this ManageEngine. That said, Azure offers an API as well, and if you wanted to, you could also check this against the Azure Active Directory as well. So I have PSExec loaded on this, so I'm going to go ahead and I'm going to launch a remote shell. Right, I've got ID 500. I can basically do anything I want to any system, any Windows system that's a part of this Active Directory domain. So I'm going to go ahead and launch. Right, I'm going to go ahead and launch a remote shell. So let's go ahead and launch this shell. So let's just check a few things. Who am I? Right. I am invisible CPN, right? So before, if you remember, I was BGC /J Smith. So I have this new client principal name that I can go in and I can basically launch remote shells on your domain controllers. Let's check the host name. So the host name is BGC DC01, and then IP config. There you see I am. That's my domain controller's IP address. So a couple of things. We've basically launched a remote shell. We've successfully used Mimikatz to do a golden ticket attack against our domain controller. So if we look on the right here, we see, right, ExtraHop has observed this invisible CPN and has actually run this query and asked Active Directory, does this user exist? And obviously this user doesn't exist. And so it's basically alerting us, hey, we've observed that this unknown client principal name is accessing parts of your network. There you'll see it's gone after a CIFS share, and it's went after the Kerberos ticket. So if we look at the detections here, and you'll see I've been doing some testing already, a few things we'll see. First thing we'll see is this PoshWeb, right? So we do check the PowerShell JA3s, and if we see those client JA3s connect to raw.github usercontent.com, we flag it, right? If PowerShell is going out to GitHub, it's probably to download malware. It's very, very rare that someone's going to use PowerShell to go get code unless it's in your developer segment. And there's things we can do to quiet that down if that does happen. But essentially, you don't expect to see those PowerShell JA3s going out to raw.github. So we have a detector that we wrote that looks specifically for GitHub, and there's a few other sites where they'll host Pastebin, and there's some another Git named site, I don't remember the name of it, but basically we'll flag anything that goes to those sites with a PowerShell JA3 hash, and that way we can just flag, hey, maybe they're going to download code. But there you can also see, again, unbeknownst to this guy, where he's spitting his serial out. Well, this time maybe the hacker can spit his or her serial out, because here we're able to detect that here someone's got a client principal name. They're moving laterally within your organization, and as the alert or the detector says, unknown CPN whose SAM account name does not exist in Active Directory. And again, what we're doing, we're simply querying using the ManageEngine API. We're querying Active Directory, and we're asking, hey, we've observed this client principal name. Does he exist in Active Directory, he or she? And if they don't, then we're simply flagging it, right? And this is definitely an actionable finding. Again, Microsoft ATA is a fantastic product, but they don't have a way today to, at least that I'm aware of, to detect when someone procures or provisions a golden ticket using a non-existent account. So this is one way where through an open platform like ExtraHop, we can leverage APIs, and multiple, your EDR, your API, and your NDR can work together to maybe find those things that using in the absence of an NDR, they don't have. Thank you for watching.